Hello again. In my last video, I went over how to get motion requirements from your idea. Today, I'll be talking about the second part, how to specify motion for a moving project, part 2. Or basically, how to match motion requirements to parts. Last time, we derived these motion requirements from a motorized scooter idea. To recap, we want our scooter to be able to 1. Move forward from A to B. 2. Be able to make right hand and left hand turns. 3. Have a freely rotating handlebar. Cool, but these are still too broad. We need to break these down further. But why? These seem fine enough. Well, that's because hardware parts are typically tailored for one specific purpose. In other words, they are extremely simple things. Our requirements right now, if you look at them, aren't simple. We have to simplify our requirements to match the simplicity of hardware. We can't go the other way, that is, from hardware to requirements, because it doesn't work. Requirements are abstract and therefore moldable. Hardware are actual things and cannot be easily changed. So, how do we do this? How do we break requirements down enough to start picking hardware? Let me tell you in an instant what took me 4 years to learn. Motion will usually fall under one of these two categories. 1. Linear. Motion that moves in a line. 2. Rotational. Motion that moves in a circle. If it's not one of the above, then it's a combination of one, the other, or both. Now you're probably skeptical. I mean, classifying anything into just two things seems extremely simplistic and naive. We can do this because parts, as I previously mentioned before, are simple. It should be no surprise then that classifying them would also be simple. You want more proof? Let's examine some parts. Hinges. These move things around the point. Think of swinging a door open. The door would swing right back into you if it was allowed to move continuously. This is rotational motion. Wheels. You know how wheels on a car move, right? In a circle. Rotational motion. Drawer slides. Pretty self-explanatory. These things let you pull out your cereal spoon in the morning without the drawer itself getting stuck. Linear. Springs. Basically, these things. These can either compress or extend in a line. Linear. I could go on, but it is pretty apparent what is going on. I guarantee that as you become more and more familiar with parts, you'll probably find this correlation to be true. Okay, for our scooter, let's classify these as linear or rotational. 1. Move forward from A to B. This one is pretty straightforward. Moving forward usually means a straight line, so it's linear motion. 2. Be able to make right hand and left hand turns. This is rotational motion. Think about what you do when you turn. Well, you move around something, and going around something usually means moving in a circle. 3. Have a freely rotating handlebar. Rotating. I wonder which one this is. Then, we need to decide if these motions are automated or not. That is your motion manual, motion that is totally dependent on you to move, or automatic, motion that requires little to no human input. Think of an umbrella. You can get ones that you have to push and pull yourself in order to open it. Those are the manual ones. Or you can get ones that open themselves with a push of a button. Those are the automatic ones. Now this is important because the parts you need vary greatly depending on which one you pick. You'll see this later. So then, which one do I pick? Depends, but generally, manual moving projects are way easier, cheaper, and faster to make than automatic moving projects. However, they are not as impressive as automatic moving projects, so keep that in mind. I'll go over the scooter example for both types in my next video, where we will start the research step. If you like this, subscribe, let me know what you think in the comments below. Feel free to throw some suggestions too. Thanks.